Okay, so the first section. Okay, the first section today is section 2.8. Section 2.8. This section 2.8 is how to add and subtract mixed numbers. Addition and subtraction. With mixed numbers. With mixed numbers. Okay, so here's my first example. Suppose I want to add the number 3 and 2/3 with the number 4 and 1/5. Okay, how would I add them? Yeah.
11/3 plus.
Yeah. I'm going to do it two different ways. Okay, so the first one would be my method 1, which is you first convert each mixed number to a improper fraction. Okay, 3 times 3 is 9, 9 plus 2 is 11. So it's 11/3. 4 times 5 is 20, 20 plus 1 is 21/5. And then I have to, what do you mean by flipping? I'm not multiplying or dividing, right?
Yes.
It's adding. It's adding, so what's the common denominator? 15 is the common denominator. So it will be 11 multiplied with something plus 21 multiplied with something. What goes in the first parenthesis?
5.
5. You divide 15 by 3, you get 5. Here you get 3, right? Okay, so then what do I have? It's 55 plus 63, right? Divided by 15. Okay, that's equal to what? It's 118 divided by 15, right? Okay, now I'm going to convert my result into, I need to convert my result now. So I'm going to divide 118 by 15, okay? Because I started with mixed numbers, I want my answer in mixed numbers. So 15, if I divide, how many times 15 goes into 118? How about trying 7?
6.
Yeah, so let's try 7. 7, so it will be 35, 3, 105. Okay? And if I subtract 8 minus 5 is 3. Okay? And then I get 1. Okay? So what is this equal to then? This is equal to 7 and 13 divided by 15. Okay, so that's the final answer. Okay. What's that? The question I started with. What's the sum? The addition of addition of mixed numbers, right? The first line is my question. Add the numbers 3 and 2/3 with 4 and 1/5. Yeah. Oh, the name for this way, there is no name. It's just that you have mixed numbers, just convert them to usual fractions, and then you know how to add them. You have already learned how to add usual fractions, right? Find the common denominator and add them. So the first thing, you can always use this method if you want. But the other method is similar. It's just that we're going to do the following. Let me show you the other way. So there is really no name for it, okay? There is no name for it. So let's do the same problem, but so I have, yeah. Let's say I have the same problem, so let's, I actually like the first way, it's simpler. But let's say I have the problem of 3 and a 2/3, and I'm going to add it to 4 and a 1/5 again. Now I'm not going to convert to mixed, fractions yet. Or what I'm going to do is I'm going to add the fractions and I'm going to add the whole numbers here, okay? So this is like having 3 and a 2/3, and I'm adding that to 4 and a 1/5, right? Okay, so I'm adding these numbers. Now, the two fractions, I want to add the two fractions separately. Okay? Now, if I add 2/3 and 1/5, what do I get? The best thing to do here is that let's make the denominators the same. So, yeah. So, what's the common denominator? It will be 15. So, let's make the first one as, if I want 15 in this denominator, I have to multiply 3 by 5. So I get 15. So I have to multiply the numerator 2 by 5. I get 10. Same thing I do here. I want to get 15, so I multiply by 3. And I also multiply the numerator by 3. Everybody's okay? Now I'm adding them. What is, whoops. Okay, give me 1 second. I have to. It's not working. Was that 3 over 15? Yeah, so I had. Okay, so basically I had 1/5. I want the denominator of 2/3 and 1/5 the same, so I want them to be 15. So if I want to get 15 in the denominator of this fraction, right? This fraction, I mean the 1/5. Then I have to multiply 5 by 3, right? So if I multiply the denominator by 3, I have to multiply the numerator by 3. So that's why I'm getting 3 here and a 15 here. Is that making sense? You multiply the numerator and the denominator by 3. Multiply the numerator by 3, multiply the denominator by 3. Okay? So that's going to give me 15 in the denominators. No, now I add. Okay, now I add. What if I add 10 over 15 and 3 over 15, what do I get? 13 over 15. 13 over 15. If I add 4 and 3, I get 7. I get the same answer. Right? You find that easy? Okay, wait for, let me do another one, okay? Okay, go ahead and write it down, and I'm going to do another one the same way, okay? Another method. Now, the problem arises is that if my numerator is bigger than 15, then I have to convert it again, okay? So that's where the problem might come in, okay? So that's why I don't like this, because I have to convert to fractions anyway. Okay, so why not do it the other way? But you can choose whatever you want, okay? Why what? Because I have the fraction 2/3. I want the denominator to be 15. So I have to multiply the denominator by 5 and the numerator by 5 in order to make that 15, right? So that's my final answer here. You guys are done writing it down? You can copy it from someone else, okay? Another example. Another example. Let's say I want to add 5 and a 3/4, and I want to add that to 9 and 5/6.
Which way you want to?
I'm going to do it the second way, okay? So I have 5 and a 3/4. I'm adding that to 9 and 5/6. That's what I'm trying to do. Now, 12 is good enough. 12 is the common denominator. 4 divides 12, 6 divides 12. So I can pick the common denominator to be 12. So the first one, if I want 12 in the denominator, I am multiplying by 3, right? So I'm going to get 9 here. If I want 12 in the denominator, I have to multiply by 2. So I'm going to get a 10 here, right? Yeah. Why? Why 12? It's a common denominator, the least common denominator. Remember how to find the least common denominator? Let me do it separately, okay, with a green. What are the denominators here? 4 and 6. These are the denominators, right? How do I find the least common denominator? 4 is the same as 2 times 2 or 2 squared. 6 is the same as 2 times 3, right? And then the LCD, you take the highest power of each prime. So you get 2 squared and 3, right? So then what is that? 12. Questions? We are picking the LCD.
Why is added 9 in the above that 12?
Oh, I want 12 in the denominator of the first fraction 3/4, right? Well, if I want 12 in the denominator, I have to multiply the denominator by 3. But if I multiply the denominator by 3, I have to multiply the numerator by 3. Otherwise, I'm changing the value. Okay? So I'm multiplying the numerator and the denominator by 3. In the second one, I am multiplying the numerator and the denominator by 2. Questions? Okay, now, so I'm going to add these two now. If I add, first I have to add the fractions. Okay, if I add the fractions, what do I get? I'm going to write that. Let me write it in pink. Okay, I'm going to write that as 19 over 12, right? 19 over 12. But the numerator is bigger, right? What I have to do is write this as a whole number plus. So I'm going to do is divide 19 by 12. So 12 goes into 19 only once. So 9 minus 2 is 7. Okay, so that means this number, 19 over 12, that number is the same as 1 and 7/12, right? 1 and 7/12. So I'm going to write 7/12 here. And that 1 I have, it will be added to this 5 and 9, okay? So that's 9 plus 6 would be 15. Making sense? Questions? Yeah. Yeah, well, 9 over 12. I mean, what we want to add the fraction. How do I add the fraction 3/4 and 5/6? How do you add 3/4 and 5/6?